Well, welcome back. I am doing a video now on the process from pretty much start to pretty much finish of how I print something. As you see, I've got a Robo 3D printer with standard matter control, which is the program that comes with it. I guess the first thing you should probably consider is, what do you want to print? You go to Thingiverse, and there's like a ton of stuff. There's also various other websites. Some require you to pay for it, so that's why you should check out Thingiverse first. Anyway, so if you've seen in other videos that I've made, one of them, a couple of times, I've gone over this toothpaste roller thing, which broke right off the bat. And by analyzing the break, I could see that I didn't have the infill cranked up high enough. It was probably like 25% infill, if that. So I should have known better. So I've gone in here already and done it, but going in and tweaking the infill settings, I've got it set to 1, which is solid. Anything lower than that, like 0.8 or 0.5, that's 80% or 50%. You could also throw a percentage sign behind this and it'll do it. And with this, it's best to do lines if you're going to do solid, because triangles and all that other stuff just doesn't work. If you're ever wondering, starting angle, I go to layer view. This one day will be done doing, it'll show you the layer view. And this is the very, very bottom layer. This stuff right here is the support material, because the thing's going to be kind of up in the air on parts of it. And if I do arrow up, it just starts going through all the different layers. And all that solid black stuff is solid plastic. It's going to be solid infill. That's the actual part that's printing. And as it goes, and there's like 1,000 layers here. See the transition between, starts laying down the solid. And going up, there's a little gear thing that locks it into place. And then this is the actual entire shaft, vertical shaft. And that little line, if you can see that, that's support material, because there's a slot in this dowel shape. So I probably don't even need to print that support there, but it's easy enough to take out. I don't really care. No big deal. But if you were to change this to a different pattern, like a triangle or something, I don't even imagine. I can't even think about how it would do a solid infill with like triangles. I don't, no comprende. It's not going to show. It's just going to be solid black like that. The starting angle though, 90 degrees. If I selected grid for this, it would literally just be a lattice, just a grid. And 90 degrees, I've got it set up to where it's literally up and down, left and right. But you can crank that over, I think it defaults to 45 where it's all diagonal. But a lot of the stuff, if I'm printing something square and it's, like that on the bed, I kind of want even support material touching the edges. If I do it 45 degrees, then the left edge will have hardly any infill touching it. I said support material, I meant infill. So you'll have hardly any infill touching it on like the left, and then on the right it'll almost be solid, because just the wonky angle of the 45. So you change that depending on what you need. I'm not going to get all the way into this. The other thing is support material. This is kind of dummy proof to a certain extent. Don't do grid, because I did grid one time on a very, very large object because I didn't know any better. And I don't know if you can see that too good. See the glare right there. This was just about impossible to chisel off. I mean, I was whacking at that thing for a while. because that is just some stupid strong support material. Support, and I mean the word support this time, because I like to never got this thing off. So I always use lines. It comes out finer, delicate. You can destroy it to get it off real easy. That's my recommendation. So anyway, what I've done is I've gone to the infill, changed it to solid. I jacked up the support material all the way. See, dummy proof. Lots, I mean, lots, standard and little. I mean, anyway, it's a technical term. I see. So, sorry. So I got it on lots because I want this sucker to stick to the bed, and I want it to stick good. It's going to be, you know, this tall. Sorry, it's going to be like that tall off of the bed, in a little skinny thing, and it all moves around, and I don't want it falling over, or I want to minimize risk. So I've got a nice footprint there that should all help it stick to the bed pretty good. So with that being said, the next step, get your SD card. I don't like printing it from the computer because it just hogs the computer. But plug in your SD card. Yeah, I know. And oh, yeah, I should say that. High quality. High quality, that's 0.1. Medium's 0.2. Low is 0.3. So I do high quality because your layer adhesion is better with thinner, little bitty skinnier layers, I guess. So there's that. So you just go export. Export is G-code. Make sure it saves to there. Yeah, you can rename it. I don't need to save. Preparing the slice model, ready to print. This is just previewing it. And I should be done. Yep, there it is. Eject. Yeah. Get that out. And there's a little slot in the side of the printer. Plug that sucker in. Then you got to plug your printer into your computer. Personal confuser. A wise man once said that. So, get this out of the way. So, like I've said before, I like a lot of glue stick. And I've printed some pretty large flat objects, like if you ever saw my other videos, this thing, that was pretty long. And it didn't curl up too bad. And that was even before I started going insane with this glue stick. But I like to put on a layer, nice even layer. And then, yeah, you know what helps? Turning on the printer. Squeezing behind the camera, not knocking it over. Okay, printer's on. Let's go back to this guy. So, connect. And while it's thinking about that, go to controls. So I'm using ABS, of course. So sometimes I have specific settings. These are all presets, but I go preheat, and get this sucker rolling. I got to change filament. I'm not using black on this. I'm going to use this blue that I don't particularly like. And you can see the temperature climbing. It's all in Celsius. I gotta say, metric is nice because, you know, 10, 20, 30 instead of 3/4, half, 14/16, 180 32. God, I would have done much better in school if we were on metric. Seriously. Probably why the United States is ranked as like pretty stupid, I guess. Everyone goes, oh, stupid Americans. Because, yeah, you know why? Where's America? So, I gotta let this thing heat up. Yeah, very exciting. This is gonna take like forever. But I gotta wait until it hits like 185-ish. And then I can swap out the filament. Because it's down in the extruder and it's pretty much a solid hunk down there. And if I try and yank it out hot, I'll probably just break it off down in there, and then I have to disassemble the whole thing, and then there'll be a lot of crying and calling my mother, and it's just not going to be fun. So I'd rather just wait a couple degrees and let that thing get going. Until then, I'm going to move the camera. Did I mention I'm not a professional camera person? No. So, brother. Yeah, here's this tripod thing that's supposed to make life easier. So, there's the filament. Hope this works out. Oh, man. Other thing that helps. Dropping the carriage so you can get at it. Filament clip. And a lot of them have a little groove so you can tuck the filament in, which is fine and dandy, but it doesn't always work out. I think that's in. It should be in. I hope it's in. Let's find out if it's in. Yep. Switching out the bottom, that means it's in. It's all still black, so. These are for it. And let's see, we'll and there's something about it. I'm a kid from, you know, I was mostly the 80s. So for me, this is kind of amazing. I can click a button on a computer and have a mechanical object move around. It's just like, my like 12-year-old self is just going so we've got that moved over. Let's do an extrusion. You can tell if the nozzle's clogged by if it comes out straight or not, but what it's doing is curling up and going back and touching the nozzle. So, but it is pretty straight. Why does it do that? Clock. Okay, well, we're at 238 degrees. The bed is at 80, just the way I like it. And then we go and, we go and do something important. We remove it from there And then you got to go load files from SD card, otherwise we'll print it from the computer, and my battery's almost dead. Pick the correct one. Oh, and while we're on this thinking of things subject last minute, one more layer of glue. There's already like 3 on there. And once the bed's hot, that's the cool thing about this stuff. It's purple. And it turns clear, well, mostly clear, whitish, clear. It's not purple anymore, let's say that, when it's dry. So you can tell right off the bat, bam, it's dry. I'll slather another one on it. Now that's what I've said before is, if you're looking for a really nice, smooth, glass-like surface between the bed and your print, that's not going to happen if you use a ton of glue stick. Unless you like really clean that sucker off. I mean, you got to clean it. This is the bottom surface. Yeah, I had a little warpage. One of the first things I ever printed. And that's with, you know, like one thin layer of glue stick. But I got a little bit of warpage. So you can add more glue stick and have a not so smooth finish. And not have warpage if you want. So anyway, I'll let that dry for a second. I've been known to put glue stick on the last second and not have a problem with just printing straight onto wet glue. But now we hit print. And now it's going to do a self-leveling thing. This would be probably about the time I would throw in a time lapse of this, but I have neither the technology nor the patience for such an endeavor. You're just going to have to take my word for it. Once this thing gets, you know, a layer or two going, I'm going to pause this and I'll just come back and pick up the video when it's done. And then I'll show you how to pry it off, how to clean it off if there's any goobers. Or we might come back to the hottest mess in recorded history. Who knows? Right now it's probing the bed. It's checking for any discrepancies. To see if the bed's level. Because if it's crooked, and it tries to print on a crooked bed, that's going too fast. I guess that's what 35% of 60 millimeters a second looks like. Alright. So, yeah. So it's doing loops, which gets the filament flowing good. And then once it's determined that it's done its 3 loops, it starts actually printing the stuff you need to print. Yeah, this is like a 4-hour print, and I don't feel like taking a week to upload this to YouTube. So we're already running kind of into it, like 19 minutes, like good lord. So, yeah, we'll just leave it at that. I'll do that thing where I take the phone out and jiggle it so you get sick watching it. Yeah. I don't really want to get this Oh, and here's one more crazy thing. I've got this insane fan set up. I got 2 fans on there, but there's not enough voltage to run them both at the speed that I've got it at. So I have to actually come in here and start it. There's another fan on the back. I don't want that one going yet. But I got to crank it down to 20% because if I have it any higher than that, it cools the nozzle off, and it gets angry at me. You know, it's got to be at a certain temperature to melt that plastic. When those fans are blowing, it ricochets off the bed just enough, and off the parts just enough, to cool down the nozzle to where this thing can't even keep up. It's like 238. It's supposed to stay there. But if I kick on that other fan right now, without it being a little higher up in the air, it'll cool off my nozzle. So I got to work on a different setup for the fan shrouds on this thing. I want good cooling, but geez, I don't know what to do really. Anybody got any ideas? Let me know. I tried aluminum foil and various, you know, Mickey Mouse hacks to try and fix it, and they don't work. So anyway, yeah, I'll come back to this when it's done, and I'll show you how to do the rest. Well, as you can see, the print has gone well. It's done. It took like, the thing said 5 hours or so, but it was more like 4. I don't know why it does that. So anyway, what we need to do is get this sucker off of here. Usually, sometimes, you can just pick them off. But not always. I think it depends on the humidity in the room too. So what we do, get a corner under there, pop it off. And sometimes brutality is required. Savage. And there is support material, the thing I want to keep, which is actually pretty smooth on the bottom regardless of the amount of glue. And just get a little screwdriver or something. Oh Lord, that's a hot mess right there. I appear to have a dent, don't know why, and a little bit of burnt bit right there, and some serious sticking right there. That is not a first, but is a very rare occurrence, and I don't know why. Same thing on that side. It's like the material. Oh yeah. Probably because it's solid, and then the plastic contracted because ABS cools when it cools. Shrinks when it cools. So, yeah, that's probably what happened. But that's not the end of the world. And then you've got this center piece, which I have to find one of my hundreds of little tools. That's where these come in handy. You can just grab it. Not while holding it at a weird angle in front of the camera, but you can just grab it. Okay. And pop it out. One piece. Which is fine. And then, since I've got these boogery looking bits, Okay, so really not half bad. Make it nice and pretty for when the kids break it. So then we get our handy dandy acetone. I am all out of jars and junk to put this in, so I just put it on top of the lid of a mason jar that I got. Then you take your brush and slather. It's not slathering really going on, this stuff's so thin. Get a nice, just get it wet. You don't want to work on it too long. Ooh, interesting note. That end was the end that was on the bed with the glue. There's plenty of times that come about where you pull it off and a lot of the glue goes with it, and you got the glue on the part. Well, the cool thing about these glue sticks that turn purple when they're dry is, or not purple when they're dry, they turn white or clear or whatever, is when they get wet again, they turn back to purple. So if you're using something nice and water resistant here like ABS, and you've got glue on there, you just run it under some warm water, it'll turn purple, and then you just rub it with your finger until it comes off. Very handy. So you can see if it's there or not. Another side note, when you're a video or two ago, it's going on about tools. The big bin that I've got with all the moisture absorbing silica gel desiccant stuff in it is there because you don't want moisture getting into your filament, and that usually applies mostly to PLA, which is why I don't really use PLA, because I'm thinking, okay, if I can't have the filament, just raw, unused, on a spool filament, exposed to moisture because it's going to screw it up, what's that going to do with my finished product? You know, I mean, is the thing going to swell up and just look horrible? Fall apart? I mean, the PLA is supposed to be biodegradable, I think, so, you know, I live in northern Illinois where it's nice and humid and stuff, and if anything is going to biodegrade, it's going to be here. So I don't use PLA unless it's just some useless little model, a toy, a gadget, just something, you know, dumb. But I made a giant skull out of PLA. You know, I mean, big deal there. It's not functional parts or anything. It's just a thing. So anyway, that has been soaked in ABS. Kind of blow it off a little bit. Go back for another coat when it's completely dry, but it is almost completely dry already because, well, it's acetone. And all the acetone does is it eats the plastic and it dissolves it slightly. If you really are soaking something in an ABS part in a lot of acetone, especially if you're vapor smoothing and you have to leave it in there for an hour or something, you'll come back to a very, very soft piece of plastic. And if you've got like something like this, where it's thin little walls, and you left it like this, there's probably a good chance that it'll soften up to where that'll start bowing if you leave it in too long. If you leave it in way too long, you'll end up with a pile, a puddle, a big snot of this on the, you know, bottom of wherever you're doing your acetone vapor. I mean, it'll just totally bleh. That's what happens. You can't really see, but in there is blue ABS filament that's been dissolved in acetone. And really, I just threw some spare chunks of, you know, like support material, and a couple of screwed up prints. You know, I just kind of busted them up and chucked them in there, and they just melt. You don't want to go crazy with this stuff. I am going a little bit crazy with this stuff. Alright, I guess that's good. So anyway, hopefully you've got the idea. It's pretty much the whole process. The only thing left to do would be like to assemble that. And what I'm going to do, this little cap is what holds this whole thing into the rest of it, wherever that thing went. Here it is. The rest of it holds it in. So I'm just going to, once that's actually dry, I'm just going to put a dab inside there, stick it on, and that'll weld it on permanently. The only way to get it off would be to break it. So I hope you learned something. If you got any questions, comments, or concerns, please drop me a line. I'll be happy to try to answer that or find out for you. And if you haven't already, please subscribe, because I don't have any subscribers and it's getting depressing here working alone. So talk to you later. Thank you. Bye.